Hi everyone, it's Mr. Kwan here. I just wanted to give you a quick tutorial on how to do regression in Microsoft Excel. You should be able to access Microsoft Excel with your college email. So if you open up a new Excel file, I have taken this data from the World Health Organization daily situation reports, and I have specifically pulled the data between the dates of February 22nd, 2020 and March 15th, 2020. And the reason that I chose these dates was when I initially pulled this data, it was on March 16th. And so I also wanted to create a new column that says the number of days after February 22nd, 2020. So those are starting from 0 all the way up to 22. And then the last column in my data is the total number of confirmed cases of COVID-19 worldwide. And notice that these are not the number of new cases, these represent cumulative totals. And so if I wanted to calculate the number of new cases, I would calculate, like for example, this value minus the previous value. So these are the total number of cases on any given day. So if I want to create a scatter plot, the way that I do that is I would highlight my input values and I would highlight my output values, and I would go up here to the Insert tab, and then there's a button here that says Recommended Charts. I can click that, and then if you hit this tab that says All Charts and come down here where it says X, Y, and the word Scatter in parentheses, if I click that and then click this second option here, that will produce a scatter plot for me. And notice that the axes are not labeled. So if you come up here, you can add in axis titles for your graph, which is something that you want to do for your project. So here I could write total number of confirmed cases of COVID-19 worldwide. And then similarly, you would do the same thing for the horizontal axis. Now, in order to come up with the equation through regression, we can right-click on any of these data points and then click Add Trend Line. And this little sidebar will pop up and it automatically populates with the linear option chosen. And so this line here is called the line of best fit. And so that line represents the line that is as close to all of these points as possible. And if you click on this checkbox down here that says Display Equation on Chart, then that will populate the equation. And it would probably help if that was a little bit bigger. So there we go. We have y equals 3001.9x plus 67,213. Now, if we want to use that equation to figure out an approximation for the number of cases in a or on a future date. So let's say that I wanted to approximate using this model the number of cases on November 1st, 2020. I'm going to go ahead and add that date there, and it would be helpful for us to figure out how many days after February 22nd that is. And the way that we'll do that is with this handy formula that Excel already has for us. So in this cell here, I'm going to create an equal sign and then write date diff with one F, and that stands for date difference. And then I'm going to put open parenthesis, and we want to put the starting date. So I'm just going to click this cell here, which is February 22nd, and then put a comma, and then click the cell that has the ending date. and then put another comma, and then the last entry, we just want to type the letter D inside of a set of quotation marks, and that tells the formula that we want to find the difference in those two dates in the number of days rather than like months or years. And then I will close that parenthesis and press enter. So it turns out that November 1st is 253 days after February 22nd. And then we want to calculate using that value as our input value in this equation, this linear equation. And again, Excel will kind of do that for us if we write equals and then 3001.9 times, and then I can just click the value in this cell, and then plus 67,213. And if I press enter, that will estimate it for us. So when we have done linear regression, the approximation using this model says that on November 1st, there will be approximately 826,694 confirmed COVID-19 cases worldwide. Now, I'm also going to do the same thing using exponential regression. So I have this here, it's the same data set. I'm going to highlight those and insert another scatter plot, exact same thing that I was doing before. And then if I right click on any point in our data set, we can click add trend line, and then instead of clicking linear, we would click exponential and then display that equation again. Okay, so this might look a little bit different than what we're used to. Generally, we've seen exponential functions in the form y equals a times b to some power x. And so if you wanted to rewrite the equation without having e, what you could do is we could compute e to that power. And the way that you do that in Excel is you write equals exp. So if you look here, it says it returns e raised to the power of a given number. So exp parentheses and then 0.0288, which is the exponent that we have here. And if I press enter, that is my new b value. So if you wanted to rewrite the equation, you could write it as y equals 71,578 times 1.029219 to the power of x, like that. So if this seems a little bit foreign, we can rewrite it like that in the form y equals a times b to the x power. And again, if I wanted to approximate the number on a specific date like November 1st, we saw previously that that was 253 days after February 22nd. So I could write equals 71,578 times power, and that just raises some number to a power. So we're going to use 1.029219 to the power of 253. And so I'm just going to click on that cell right there and then close the parentheses. And if I press enter, this model is approximating that on November 1st, there will be about 105 million cases.